Welcome to the shop. I'm continuing in NQALHA Production Run 5 on my new Haas Mini Mill 2, and things are going extremely well. As I've said in previous videos, I'm working on developing procedures and checklists and developing habits and always paying attention, because the machine just surprised me a few minutes ago. It kind of, for some unexpected reason, randomly loaded a program I didn't intend. I'm definitely going to report the bug to Haas, but it just reinforces the philosophy: always look at the screen, look at the G code, put in lots of comments in the G code, pay attention, don't daydream, and just automate as much as possible. So before I start making these parts today, I'm going to demonstrate an automated probing cycle, that little piece of G code that I wrote using the wireless, the Haas Whips Renishaw probe system, where in order to prepare for an operation where I'm setting the 0 at the left rear corner of the soft jaws and the Z0 at the ledge of the soft jaws, the way that I do it is to take a precision 1, 2, 3 block, and yes, I did verify that it's the correct dimension with a high quality micrometer. So I put these precision 1, 2, 3 blocks in both vices and then run my probing program. So let's go over here and load up Mr. Probola. And now I'm doing a protected move. Actually, no, that's not correct. I'm doing a Z probing cycle. Now I'm doing a protected move to approximately the corner, ½ inch above, then executing one of their probing sub-programs to probe the corner. By doing this in a program, it kind of is one less place to make mistakes. And I like to, as I develop procedures and habits, I like to automate as much as possible. And little bit by little bit, I'm figuring out tricks and procedures for automation that hopefully will reduce mistakes. In the last week or so of doing this, haven't made any mistakes. So that's a good thing. I'm gonna take my 1, 2, 3 blocks out and put in my blanks. These parts that I'm making here, I'm making an array of 2 parts using the Bobcat array function, which is now my favorite part of the program. It works really, really well, and definitely speeds things up. This part is, the blank is a little over 2½ inches long, and I possibly could get 2 of them in side by side, left and right side of the vise. I'm a little nervous about doing that, because this operation is going to be hogging out quite a lot of material. Pretty much the whole block ends up in chips, and what's left is a really, really thin little electronic enclosure, and that's going to be a lot of force, and I'm not 100% confident that I would get uniform clamping force on two blanks that almost touch each other in the vise. So I'm just running 2 parts. So I'm going to go over here and inside array, and I'm going to, even though I've run this once, I'm going to go through the procedure that I use for running a new part, just to be sure. So I turn on option stop, and the G-code contains an option stop after every tool change. If you've been watching these videos, you remember that the mini mill has a rather serious limitation that the 20 pocket tool changer is limited to 20 tool numbers, unlike the Tormach, where you could put any tool number in any pocket and it would just figure it out. I have to deal with it somewhat manually, somewhat automatically, using the Bobcat scripting language in the post processor. So I have a listing of my standard tool set, the standard 14 tools that are always in the tool changer, and then I have now 9 optional tool sets of 6 tools, and depending on the part that I'm making, I look at the G-code. It tells me what tool set is being used. I look at the piece of paper, load up the tool carousel appropriately, and then when I'm running a program for the first time, I put in the option stop, look at the G-code comment, and the G-code comment tells me you're supposed to be using whatever, tool 41, and then I look, I've got every one of my tools is labeled using Dymo labels, and these are supposedly chemical resistant, and so far they've been holding up pretty good to the solvent. So change a tool, optional stop, look through the window at the tool number, look at the screen to make sure that the correct tool is in the is in the spindle, put it in single block mode, 25% rapid, choose distance to go in the display, and then single step, look at the distance to go, single step until I'm confident that it's not going to be insane. Then I turn off single step, run that tool, rinse and repeat. So let's go ahead and start the sequence. And once again, I've already done this, I've already run this part, so I don't need to do the startup sequence, but I thought, hey, what the hell, might as well show it in case anybody's interested. So, tool 48 in the spindle, H48 in the G-code, setting to single block, 25% rapid, looking, distance to go 0.8 looks sane, distance to go 0.1, and it looks sane, so I'm going to turn off single block using a Lakeshore Carbide 3/8 3-flute, what they call the aluminum shredder, and this is a roughing tool that makes very, very fine chips. And fine chips with a deep pocket like this, fine chips evacuate really, really well using the excellent flood coolant. I'm doing this in 3 passes, approximately 300 thousandths per pass at 200 inches per minute, 10,000 RPM, using a HSM toolpath and the HSM machining mode on the mini mill. Now I'm moving over to the second part in the array and repeating the whole thing over again. I'm using a spiral entry instead of a plunge to enter the part. If you plunge a tool like that into the part, it ends up producing a rat nest of chips wrapped around the tool. And so using that spiral entry keeps the tool clean and keeps the pocket clean, so I don't end up with a lot of chips getting in the way and potentially getting cut and recut and building up on the tool and breaking the tool. So now going to choose the next tool, which is a 1/4 inch, tool number 6, tool number 6. Going to reset to 25% rapid, single block mode. This is a long tool. My normal 1/4 inch end mill only has a 3/4 inch depth of cut. This is a longer one that has a 1 inch depth of cut. So I've got my finger on the stop button, looking to see distance to go. Looks reasonable. Feed down, feeding in, single block off. I'm doing this in 2 passes because trying to do a almost 7/8 deep finish cut with a 1/4 inch tool. I've broken tools doing this before. This is a 3-flute Lakeshore carbide, zirconium nitride coated 3-flute solid carbide. I think I said that. And it's running at 60 inches per minute, 10,000 RPM. Okay, back to 100% feed. Changing tools, tool number 49, H49. Gonna 25% single block. Distance to go looks sane. Single block off. Drilling a couple of mounting holes with a 3/16 drill bit running at 10,000 RPM. Love that 10,000 RPM spindle. I'm so glad that I got the high-speed spindle. Tool number 31, H31, and single block 25%. Distance to go looks sane. Everything looks sane. Full speed operation. And there we have it. So this is the inside of these parts, and this happens to be the part on the handle of the NQALHA where the little push buttons and the thumb wheel optical encoder for speed control all fit into here. And that's the inner pocket. And then for the next operation, I'm going to mount it to a tooling plate and do the outside. And then the 3rd, 4th, and 5th operations, I need to drill holes around the outside edges of it at weird angles. And so that's going to be ever so slightly interesting. So that'll do it for today. I'm going to go ahead and run the rest of the batch. I'm nearing the end of the aluminum parts. I've only got, I think after this one, I've only got 1 more to go. So, wow, the end is near. And once again, this machine is performing magnificently. I can't quite say I've mastered it, but I'm getting so much more comfortable, not making mistakes, going a lot faster, a lot more accurately, and just making good parts and having fun. The first operation has been completed successfully, and the parts are sitting on the work table. Now, for the second operation, I did a little bit of more advanced fixturing compared to the way that I used to do it on the Tormach, and also constructed an HSM toolpath. And I had a little bit of difficulty trying to make this work in BobCAD. BobCAD is sometimes rather challenging to figure out how to get everything to work, and I eventually got it to work in a kind of a roundabout, kind of a not very efficient way involving a lot of handwork. And who knows, maybe someday I'll learn the trick and be able to figure out how to do it. But some things in BobCAD seem to work well with a 2D drawing, and then some things seem to work well with a 3D drawing. And just in general, I'm so confused that I basically use the tools I understand in ways that I understand because I want to get the job done. And maybe eventually someday, if I ever have some leisure time, I'll try to figure out how to make it work, how to generate this toolpath more efficiently in BobCAD. But for now, with a lot of handwork and a lot of roundabout work, I have a toolpath that works. It's an array of 2 parts, work offset 1 and work offset 3. I've made some improved fixtures here, and the fixtures have little precision pins and a hold down piece that is that also has matching holes. And so when I put my first operation parts in, I get the safety glasses on, put the first operation parts in, and then get my little custom machined hold down in place. It holds it down very securely. I'm going to be doing some fairly aggressive outside cutting with the HSM toolpath and the Lakeshore Carbide aluminum shredder, so I want to make sure the parts are held on really well. So I've already tested and debugged and run this program a couple of times, so there's going to be no surprises and no back to the CAD room, got to figure that out. So let's do an outside profile. And this part was finished. Here's one of the finished ones. Maybe you can see it there on the camera. There's not much aluminum left. It is a thin wall part, and the vast majority of the blank ends up as chips. So here we go, just checking everything to make sure that all is well. Starting off with the aluminum shredder 1/2-inch tool, running an HSM toolpath, 250 inches per minute, and this is doing a full depth of 1 inch, and I'm using a 50,000 step over. And as I look at the spindle load, it sometimes hits 90%, but it's mostly in the lower region. I could probably be a little more aggressive on it, but this is the part that I kind of had difficulty figuring out about how to get that included in the HSM path, and just couldn't quite figure it out. So doing the second part. The aluminum shredder is a marvelous roughing tool, produces very fine chips, does a really nice job. I just got the 1/2-inch one, so in some of my previous videos I'm doing the HSM roughing just with my regular 1/2-inch straight flute cutter, and I like the roughing cutter a little bit better. So that completes the roughing operation. Now I'm going to do the finish operation with the 1/2-inch 3-flute solid carbide zirconium nitride coated, also from Lakeshore Carbide. And this is running at 90 inches per minute, producing a beautiful surface finish. Then I'm going to drill and tap a couple of holes. Using the stubby drill bit, the screw machine length drill, so that because the stick out is so small, I can get by without using a spotting drill or any kind of centering drill. I just use the stubby drill and poke it in, and the hole comes out good. So 832 tap. Everything is going well. And kind of sneak my hand in through the door to blow the coolant. And that does it for second operation. I'm going to go ahead and run the batch of second operation. Then the third, fourth, and fifth operation, I need to drill holes around the periphery of the part, and none of them are at right angles, and there's no convenient surface to grip the part, so I end up making another fixture and have some handwork in between. I'm going to program in a bunch of M0 stops and basically drill a hole, stop, open the door, flip, drill, and there's going to be a lot of opening the door. So that does it for second operation. The project is nearing its conclusion. The aluminum parts are almost finished. The steel parts should go pretty fast, and things are going really well. So I'm going to turn the camera off and see you later. All of the second operations have been completed, and everything was going really well until my air compressor died. So I ended up having to take a little diversion from the plan and see if I could find an air compressor motor locally. And sure enough, I was able to find one, but it was a kind of a nervous thing there for a while, thinking, oh no, now I'm going to have to order it and wait and delay the project a little more. So anyway, air compressor's back in action, I'm back in action, and the part that the operation that I'm doing now, let's see if we can get this on camera. This little part has to have holes drilled at a variety of different angles. And in order to do that, I made some little fixtures, and they kind of look like that. And then came up with a toolpath program that has M0 stops in it, so I can drill a couple of holes, stop, reorient the fixture, drill a couple more, reorient, drill a couple more. So not that exciting, but oh well, gotta get it done. So let me put on my glasses here so I can see what I'm doing. Got a couple of precision pins, precision machined part here. So I put the alignment holes over the pins, and they do fit kind of tight. Let me orient correctly here. This is a slow process. So I've got hole number 1, or actually I should say position number 1 ready. And I've already run this program once, so there's not going to be any surprises, hopefully. 1/2-inch hole, using the Bobcat combo tool path and the recommended feeds and speeds for a 1/2-inch high-speed drill. Then open the door, orient the part, check to see that the surface of the vise where I'm referencing doesn't have a big old chip on it. And return to the second hole set. And of course, it's a cold day in the shop in Northern California, and the parts are cold and the coolant is cold, and so third hole. This is a 3/8 hole. The 1/2-inch holes are for push buttons, and the 3/8 hole is for the rotary encoder. And yes, I do use a very high quality rotary encoder, one of the most expensive components in the NQALHA, but you know, I like using good components. So there we have it. Just a little deburring, and then those parts will be finished. So getting very, very close to the end of the machining operation. I've got, I think, one more set of aluminum parts and then a few steel parts and a little bit of machining on the manual lathe. And then the parts will be off to anodizing and plating. So, thank you for watching. It's been fun.